Welcome and hello. This is a video lesson in the HEC RAS controller. In this lesson, we are going to be getting started with Python. So up until this point, we've been doing all of our lessons and our VBA coding and HEC RAS controller work in Visual Basic for applications built into Microsoft Excel. And this lesson, we're going to be introducing some of the same concepts, but using Python. What you see on the screen here is a simple HEC-RAS model. It is a 1D steady flow model. We'll go ahead and take a look at this quick, run the model, look at some results, and then get started with Python. All right, so anyway, let's take a look at the cross-section data. It is a 0.1% slope. There's a steady flow of, let's see, 1000 CFS. So that's coming in at the top stream cross-section. We'll go ahead and close that. Let's go ahead and run the model. So I'll click on compute. All right, that finished up. So I'll click on close and close. Let's take a look at our cross-section data. I'm going to be interested in the water surface elevation at the downstreammost cross-section, which is right here, river station 0. Okay, so the water surface elevation appears to be 37.75 or something about that. Let's check out the actual numbers by going up to View and then Profile Summary Table. Down here is River Station 0, and our water surface elevation is indeed 37.75. That's rounded to 2 decimal places. So what we're going to be doing with Python is a few things. First of all, we're going to open up the project and perform a number of the same procedures that we've been already using in Visual Basic for applications, if you've seen any of my other previous videos. So for instance, the tasks we're going to complete using Python include opening the project, updating the flow rate to 1000 CFS. So that reminds me, I should probably change it right now to something different. So instead of 1000, let's go ahead and change it to 800 CFS. So file, save flow data. Okay. Let me close that and just confirm that it's saved. Yes, 800. Okay, very cool. We're also going to compute the current plan and then print out that water surface elevation at river station 0 to the console. And then I'm also going to open up the cross-section plot and data table at river station 0. So by cross-section plot, that's what I'm talking about right here. And then the cross-section data table is right here. So river A, reach 1, and river station 0. So river A, reach 1, and river station 0. All those tasks can be completed by running a script, either in VBA or Python, but this video is about Python. So go ahead and open up whatever interactive development environment you use for your Python. I typically use Visual Studio Code, VS Code, and I'm going to navigate to my project. I've already done that, so go ahead and File, and then you can go to Open Folder. So I'm already in the location that I want. This is actually not my project directory, but it's just one level up. So here's my project directory. Here are the files for the HEC-RAS project. I'm going to create my script just one level up. So I'm going to go right click, new, and then text document. I'll call this script.py and then delete the existing file extension. Okay. So this is a blank file that I'm going to write my script in. Back to VS Code. Then if I expand the project, here is my script. Here's the file right down here. And I also like to Control J and bring up the terminal window to run the script and to perform other tasks as needed. So yeah, Control J. I'm not going to describe all the shortcuts. I think that some of the buttons up here can also toggle the terminal window on and off. The first thing I'm going to add to the file is import and create the HEC-RAS controller. So I'm using HEC-RAS controller version 6.6. So you have to include that RAS 66.HEC-RAS controller right here. And before that, we need to include this win32com.client. If you're not sure if you have that installed, then you can do a check. So down here in the terminal, just type in pip. Okay, let's try that again. Pip, and then show py win32. And if it's installed like it is for me, you'll see looks like this. It'll give you a version number. If you don't have it installed, then what you're going to want to do is you can type in clear in the terminal to clear the existing text. You're going to want to install that by just going pip-install and then pywin32 and hit enter. Okay, so if I do that, it'll probably tell me it's already installed. We'll just have to wait for a moment. There's a couple progress bars. Ultimately, it'll tell you that it's been successfully installed. Right, so after that, I'm going to paste in some more code. So this is the entirety of our script so far. What we're going to be doing is opening up the project. So this right here is the absolute path to my project file, project.prj. And then I am referencing our HEC-RAS controller object, calling the project underscore open subroutine, and then passing it the project directory, or the path, excuse me, to that project.prj file. Now, as you notice, some of the syntax is a little bit different than what it was when writing the Visual Basic for Applications script. So just take note of that there will be a few differences. After I open the project, I'm going to show the main file interface and then also open up the geometric data editor. So let's go ahead and run this code and just test it to see if this works. Again, if you're using my exact code, you're probably going to have to update this line 7 with the specific path to your HEC-RAS project file, so not PRJ file. Okay, so to run it, there's a few different ways. What I'm going to be doing in this lesson is coming down here to my console, make sure the file is saved, so Control S. I'm going to be calling Python, Python, and then the script, script.py. Now, the reason I can do this is because I have Python installed on my computer, and I've already set up an environmental variable so that Python here calls my version of Python, the specific executable. So it's basically like a shorthand. Also, script.py is very much a shorthand as well. The reason I can do that is because I'm currently located in that directory that has a file called script.py. Okay, so if you don't have Python installed on your computer and set up with the environment variable, there's plenty of tutorial videos on YouTube that I can explain that process. But I'm just going to go ahead and run this. I'm going to go ahead and run Python now. So my HEC-RAS is currently closed, and then enter, and then boom. So HEC-RAS has opened up. So that's cool. I have the main file GUI on top, and then I have the geometric data editor dialog box down below. Okay. So I'm going to close that. That's good. Also, I'll just click clear. If you want to run previous commands down here in the terminal, you can just hit the arrow up button. It will automatically enter the previous command. If you hit up again, it'll give you the previous command before that, up again, the previous command after that. So that's how that works. Okay, next what I'm going to do is programmatically update that steady flow to 1000 CFS. So before I do that, I'm actually going to run the script again, open up HEC-RAS project. I'm going to click on the steady flow data and just confirm that right now the flow is 800 CFS. Okay, so that's good. I'm going to save everything, close HEC-RAS, return to my script here, and then enter this block of code. It's going to set the steady flow to 1000. So this is an array, this flow array. In the first entry, index 0 is 0, and then in the first entry, it's 1000, and that's the CFS, the flow rate. This 1000 up here on line 15, that is the river station number. So the first three parameters here are strings, and then the parameter here is an array with the actual flow rate. Okay, I probably could have done this differently and started the indexing at 1, but that's fine to just have kind of a placeholder for 0 here that's not used. Let's go ahead and see how that works. So save. Control J to open up my terminal, and then run the script. So same thing as before, except this time when I go up to check the steady flow data, boom, it looks like our flow rate has indeed updated to 1000 CFS. Okay. Awesome. So let's save that, close, and close HEC-RAS. Next, what I'm going to do is everything else. I'm going to run the simulation. We're going to print out the water surface elevation and also show the cross-section plot and table at river station 0. So let's add something starting here on line 19. Boom, all of this down to line 49. So what I just pasted in was this right here. Let's just start from the top. We are first going to run the simulation. So to do that, we'll call the compute underscore current plan, and we'll send it the message count and the number of messages. This took a while for me at least. If you're sending function and array, I needed to initialize it to just none. And then after that, we are getting and printing the water surface elevation at river station 0. So to do that, we're setting water surface elevation equal to the output of this function, output underscore node output. And then we're passing it these 6 variables here, all of which are integers. In Python, there's no integer versus long integer. It'll resize as necessary, and you don't have to prematurely define the data type of a variable like you do for VB or C. So that's all handled behind the scenes. And then what we're doing here, the water surface elevation, it's returned to us in a tuple. So I'm unpacking that, and then I'm rounding it to 2 decimal places. And then I'm just going to print it to the console window or the terminal window with the string water surface elevation at river station 0 equals, which should say 37.75 if I remember correctly, feet. And then after that, we're going to be opening up the cross-section plot here at river station 0, as well as the cross-section data table at river station 0. So I realize I am kind of redefining some of these terms multiple times, but I'm just doing so to sort of be explicit because that's what's required for the parameters in each of these function calls or procedure calls. All right. So I'm just going to leave everything open here. I'm going to save the project, but then that right there is the end of the script. Let's go ahead and see if this works. So make sure to Control S to save, and open up the terminal, and then just arrow up to the command where I'm running the script, Python space script.py, and hit enter, see what happens. So it looks like we're running the program right now. And then boom, here comes our results tables. So here is the cross section at River A, Reach 1, River Station 0. Looks like 37.5. We'll see in just a moment. Here's the data table at the same cross section. Oops, no, this is at River Station 1000. Wait a second. So that's supposed to be 0. Let me go back to the script real quick. Okay, so I can't explain that, but we'll get that figured out. It takes really no effort to just switch that to River Station 0. The water surface elevation right here is 37.75, so that looks successful, plus all of the other data we could look at if interested. And then the last thing to check is retrieving the actual value, 37.75, and printing it, which we should be able to find out if we close everything here, go back to our terminal window, which is, boom, right there. Water surface elevation at River Station 0 is 37.75 feet. Last thing I wanted to mention is we don't have to invoke this script within Visual Studio. We can also run it just from a command line because we have a Python script right here. It's saved on our computer. So I'll just go ahead and do a quick demo of that, and it's going to just run the same program as before. I'm going to build my command in this text file right here. So first what we need to do is reference the Python executable, which I found on my computer right here. Oops, let me expand this all the way. So it's going to be C drive, users, and then my username, and then app data, local programs, Python 3.13. I've got a few different versions here, but let's just go with the most recent. So python.exe, I'm going to go right click and then copy as path, go back to my text file, and then that right there will be the first argument to the command that I'm going to provide. And then we want a path to the script. So right click on that, copy as path. Let's go back to our command. So give it a space and then paste in the path to the Python script. I'm going to highlight that entire command, Control C to copy, and then open up the Windows command prompt is what it's called. To paste, you can just go right click and then hit enter. And then that should run the same script that we did run using the Python code within Visual Studio. So there's that. We have the cross-section data. Then let me just close everything up. Yeah, we still have the printout right here of water surface elevation at River Station 0 equals 37.75 feet. All right, well, that's it for this exercise. What we did was got started with Python using the HEC RAS controller.